USART in SPI mode.
This is a bit more.
You can.
Добре, аз ще се го намеря, ще видиш. Има на идея как бих го погнал.
Well, I'm writing. Actually, this is for our careers because I'm not working in a software.
Okay.
The battery is there. Sorry.
And they call it or they put it? No,
So I want. I just want to excuse myself. I don't have experience in presentations, so you understand that I'm a little bit confused now. It's not so bad, but we have 12 times to improve myself. Probably at the end will be okay. Where is my slide? Yes, it's over here. I will just take probably half an hour more of your time, and we'll go home after this. Next time we'll be much more focused on physics and the semiconductors actually, and the processes used to build integrated circuits. They are connected to this software which I showed you, the schematics, the simulators, and the layout at the end. Everything is connected, so we can't say, for example, I will show you how to use KeyCut, and I want from you to make an operational amplifier or something work digital stuff, for example, because it is just a tool, and you won't understand the nature of the components and why there should be there. So my idea is to show you the basic principles, and after that we can build when we have some basic understanding, we can build more complicated circuits and improve them. So the next software which I'm going to use in the course is LT-Spice. It's very useful tool. It's also similar to Quicks. I prefer Quicks because of the interface. You will see now why LT-Spice is I don't like it so much, but LT-Spice uses some codes from Berkeley University, where the first version of Spice is abbreviature for I forgot but we can check it. Simulator, it's okay. Simulation program with integrated circuit emphasize. It was developed in 1973, and it has 3 versions till now. This is it uses standard modules for transistors and diodes and resistors and so on. The idea is to have a model, put some parameters in it, place it in SPICE, and at the end you end up with some DC parameters like we view on Quicks. DC parameters, for example, the voltage drop or the current dissipation. We can there are much more complicated parameters that are extracted from the current and the voltages. And in basics, everything is related to current and to voltage. And the connection between voltage and current is the resistance. So you will see how complicated can things get when with only two parameters. There are some RF parameters at the end. So with these parameters you can optimize your circuit to work with different conditions and with different performance. So we will see this, but LT SPICE uses some kind of SPICE in it, but it has also harmonic balance and some useful features in it also. I'm using it in Wine because there's no Linux version, but the people from Linear Technologies claim to optimize Delta SPICE for Wine also, so it will work in Linux using Wine. So here you can see the interface. Here we have inductor, capacitor, resistor. We can place components, operational amplifiers here. These are from Linear Technologies, LT, and so on. Just to see how, just to show you how it is looking like. We have also examples. For example, we can look at the band gap. The band gap is a very useful circuit, and it can be, as you can see, we can simulate the circuit from -55 to 125 degrees. For example, at this point, if I place a cursor here, I can see how this voltage is going to change when I'm changing the temperature. So these band gaps are used for voltage reference, and here the difference is at the third point of the third sign after the point. So for example, here you can see that this circuit improves with not much. They are all good circuits actually here, but we can see much better performance. You can see it goes at the fourth of the So you can make such circuits and simulate them. The good thing about the LT Spice is that the manufacturers provide models of the transistors and or integrated circuits, operational amplifiers, if you are going to use such things. And you can see that here the model is N-type, NPN. How does it look like? We can see Spice netlist. It's the same netlist as in KiCad, but we have different nodes and different connections. Actually, there is a definition. If you place here Q1, this means that it's a transistor and it's called Q. With Q are defined the transistors, with R are the resistors. Then you are placing the first node, second node, third node, and so on. It's actually text file which you can modify. You can make your own circuits with such netlist and simulate it without adding some components in the schematic and so on. You can use it as a background. Actually, in electric, they are using to I didn't told you, but with electric, Harvard, I think university, some people have designed a chip, MCU, MIPS technology with it. Actually, it's working. The design is published, so there is a library, and you can even simulate the whole processor, which is I'll show you. I think it's interesting, but probably here in documentation, textbook, product, libraries, yes. Buze State Standard Cell, значи Harvey Mudd Standard Cell project site. Sun also have designed their own chip in the laboratories, over 1 million transistor, and was used to measure on-chip and inter-chip capacitance structures. So it's quite simple chip, but still uses 1 million transistors, you can see. Here is the MIPS microprocessor, Harvey Mudd College. I'm sorry, I don't know why I have mistaken it with Harvard University. Harvey is not, it's some kind of college, so they have published the standard cells here. I won't download anything now, but if someone is interested, they can make even the simulation and so on. It's trying to download it, but shit, my computer blocked.
Not trying, it's doing. This is what happens when the server is set up to process the zip.
Okay, project site. Here you can see the project. It's actually the processor and its layout view. The simulations, so 32-bit. It's okay. They have verified it, so we are in LT Spice, but they are using LT Spice to simulate some of the performance of the chip. So we are going to use it in our operation amplifier.
So if you have inside, you have all these components, so you can represent them in the simulation.
Yes, but at the end, additional to these components are added much more capacitances and resistances in order to represent the interconnection and the parasitic effects. So at the end, it's this was LT Spice. I won't show anything more. We want to finish this evening. So LT Spice Blender. Does anybody know Blender? I'm going to use Blender to generate the images of actually it's a 3D software for designing animated movies, but I'm using it for different purposes. It's very easy to show you the layers here. So I should have some for example, if I want to make this cube very small, I just place here 0, 0, 1. This was not intended. Okay, I will look at my monitor, so it will be much easier. So I can make metal layers here very easy. If you followed me in the electric, there are such metal layers, and we will discuss the transistors here in 3D because it's much easier to show you and to make the explanation, I think. So we can make another on top of it, metal layer. We can change also the color of this but I need to change here cycles, diffusion color was new, settings, viewpoint. So okay. Yes, it's possible to the color to be changed. Now I won't show you how, but I'll use it for simple things, so we can design. It's very useful also for some to make 3D objects as okay, I won't continue with Blender. It's not a theme of our discussion, but I'll use it and just wanted to show you. HT twins, what is this? This is a representation of our universe, and I wanted to show you.
Nice.
Yes. Probably all of. Does anybody have seen this? Mm-hmm. Yes. Also, Ruswan have seen it. I believe so. So it's in order to understand physics, we need to be very good at sizes. That's what I meant at the agenda when I does the size matters. The things are going much smaller and smaller, and there's many things about it. Not only to have a phone in your pocket and to have camera and so many good features in it, but you need to make things smaller in order to get better performance for the transistors. That's why I want to discuss these things and to make them much higher speed. So in order to get high speed, you need to minimize the voltage and to minimize the what?
Size.
The size is effect of the minimizing the voltage drop and the current and so on. It's a complex thing, but the power consumption goes down also, and I think it's a good representation of our universe as we see it. So I'll start this flash and we'll go down to 10 to minus 35, I think so. We'll see the different effects of when we are going deeper and deeper in size, and we'll go back after that to extend the universe as we know it. So in our designs we are going to work with sizes about 10 to minus third. So it's not so much. I mean, we are going to work with millimeters and micrometers. Most of the people are not very good at micrometer level, but it's very difficult to understand something from my point of view. It's very easy to see something, for example, that counts up to 10, 20, 100 even. You can visualize it, but when you are going with millions and billions, things are getting different, and you need a reference to compare something. For example, I'll give you an example. 1 micrometer transistor, I mean the gate of the transistor, is it big or is it small? It depends from the point of view. I think 1 micrometer was a technology from 20 years ago. So it was very useful at these times, but now we are working the most I think AMD is using 35 nanometers. Nanometer is 1000 of 1000 how it's in English, 1000 of the 1 micrometer. So you understand that just let's see what's going on here when we go down. Matchstick, unfortunately, how can I make this thing to be on the full screen? There's I wanted to see
Control
the scale.
minus.
Let's check. No.
Yes.
Yeah. Just like this. I'll get here. So I just want to see where we are going to work and to have some comparison. This is the hair width of the human hair. It's about 200 micrometers, so it's quite big. With the silk fiber, this droplet, we are still haven't touched a micrometer, but white blood cell, nucleus, wavelength. When we see the technology presentation, you will see how this white is connected to the manufacturing of the integrated circuits, and there is also some animations from IBM and few good companies, so you can see them. The DNA is at almost at nanometer scale. Where was the transistor gauge? Yes. So here we are. We are viruses. We don't like them. So, but let's see where we can get. At the end, nanometers, carbon atoms. So we'll start from here next time, the physics and the structure of atom. Then we'll define the solid state crystals. We'll see the periodic table. Just I'll show them and how they are connected to the parameters of the transistor. That is the idea, and after that we will define the resistance, the conductance, the simplest parameters. We are going deeper. Gamma ray. We have also to define. We should define also the frequency and the time. It's very simple, but in order to use them, we have to define them. So I'll say a few words. Probably everyone knows what frequency and what is the time. What time means in integrated circuits. So Fem2, we are 10 to the minus 15. For example, we are going to use Fem2 farads. This is capacitance value, which are typical for integrated circuits. I mean, when you make extraction of the circuit in order to compensate for parasitics, this is the capacitances usually that are need to be compensated in this order: 30 Fem2, 20 Fem2 farads. So this is very useful when you try to compare some things. This is range of the weak force. Okay, this is not coherent. let's go deeper. Atomator. Strange quark. The boson have found them near. The people in CERN have found the boson. It's probably somewhere here.
No.
Much small.
Much bigger.
It's very big,
It's the biggest one.
but very shortly. That's why they can catch it.
Okay, here's the neutrino.
One big.
Probably we won't go so deeper, but this is related to the next lecture, not lecture, but the next topic of our course, where we will discuss the main physics theories connected to semiconductors and how they are applicable in our case. So there are three big theories, and one is the Newton's classical theory. It also have relevance to the integrated circuits and transistors and so on. The second one is the wave theory or Maxwell's theory. It's typical for the radio frequency engineers, and the last one is the most common here for the physics which is Einstein's theory about the matter relativity and so on. Yes, so they are not they are all connected, and they are used in different scales. You will see this. For example, in up to I would say nanometers, the Einstein's theory is used, because some of the Maxwell's theory doesn't confirm some of the quantum effects, while if you try to calculate the field of electromagnetic wave using Einstein's theory, you can go crazy. It's but so the things are connected, and we'll start from the Einstein's theory about and we'll define the atoms and how they affect the structure of semiconductors and the crystal of the semiconductor, how the atoms are substituted with some other atoms in order to increase the conductivity, and at the end we will end up probably with the wave theory, Maxwell's theory, and it will be good enough for our cases. So this was when we go deeper from 1 meter, and we are shrinking the universe, and when we try to expand it, we'll see what's going on. I believe elephants they are 10 meters. Just to conclude the things, probably you think, or all of you think, that this is not too much information, but when you try to understand these so small devices like transistors, and to use them to model some of the transistors, you will see that most of these parameters are actually in the model and they have a meaning and they are connected to the physical behavior and the physical device. So that's why I'm showing this now. And this is the distance from Neptune to Sun. Okay, I believe. White day, comet, Secunda, Sedna to Sun, nebula, some stars, galaxies, Magellan Cloud, and Zeta Meter. I don't have any idea what's going on here. Clusters and distance to the great attractor, and at the end it's the end of Hubble Deep Field. So the Hubble telescope have seen so far, so it's 10 to the 27th. I don't know how this number is called, so I won't bother with it. So next time we'll continue physics, some basic parts, and this is my idea about the course. If anyone have prepositions or some ideas about the course and want to I haven't taught anything about Arduino. It's a very good project. We can do some basic things at the end with Arduinos. We have 2 spare Arduinos here. If anyone wants to use it, just can tell me and take it. And please think of the next, where will be the next 6 times that we have to decide when are going to be these 6 days for appointment. Yes, we can make the decision next time, but think about it, make some plan, and I also will send all of you mails with my I have in Gmail account, and there are some books about microelectronics. They are quite big. One book is about more than 1,000 pages. There are lots of topics and so on, but they are good references. So I'll try to I'll send you an email with more information, and you can use these books as references. If you don't understand anything, something, and want to ask me or look at the book or something like this, you can always do it. So I think I am finished for today. This is thank you. So if someone have questions, yes.
The Tuesday, Thursday is not final. Or,
Why not?
well, I like it but you're asking to find to define.
So this is what I have taught. The dates are 14, which is today, 16, 21st, 23rd, 28th and 30. These are fixed dates because the WAP is empty. We can use the room here. I have keys, so nothing can stop us. And because I have defined 12 days for the course, we need to decide which days we are going to make the other 6.
You mean between these or after these?
For me it's
Well, why not continue the same way? Tuesdays and Thursday through September.
that's what I was asking. Probably it will be okay, but
This way I like
okay.
like this.
Okay, for me it's okay
The
also.
others have to tell for me.
Yeah, no problem. Although I'll have to miss 1 or 2 in September.
I'll have to miss too, but
Around 5th to 10th September I will be away, but I can just catch up the days.
Of course, yeah. It's
I'm missing the same week, so actually me too.
Okay.
Well,
we can so
if
they are not fixed.
this week we could probably skip the week, right?
Of course, actually I would like to say, probably you have seen this, but this electronics BG is a working mail list.
But where is it hosted?
Yes, probably this was very stupid from not to show it. It's in Google
Groups?
groups, yes. Groups. What I have a few groups actually about Blender. Is one of them. Google.com. So we can discuss the days there. I think actually it's a very old group, probably 2 years. For now everything is in Bulgarian, but things are changing, so we can discuss in English, it's not an issue. We have one more guy, Vladi, he also will attend, but now is at the sea shore, so I think it's good enough. With the website I can place the date when we decide which days it's going to be. I'll place them on the website. The Git, I haven't made it yet, but I'll do this. I'll do some repo, and I can add more people as a collaborators, so everyone can upload to the repo, and we can share designs. Actually, I have done lots of designs, but most of my boards are manually soldered. I don't have any electronic how to say version of them. That's why I think they are not very useful circuits. Actually, they are working, but no one can learn from them and try to make adaptation to their schematics and so on. But we can improve this thing with working, with nothing else. So.
Do you need our email addresses?
I have yours. I think you have signed up for the course. I have. Actually, I don't have yours. I think. Can you send me an email? You can get it from Minitu website. In the course, you can read the text and send me an email, and I think the organizational questions are discussed, so we can finish for today. Actually, it took too long. Sorry for the delays, and meet you next time at Thursday, probably.